Hi everyone, welcome back to today's video. So in today's video we are going to talk about entire system Verilog course in one go. Since the video will be very lengthy, I'm going to divide it into parts and upload it. And this is useful for firstly I'm saying that this video is useful for you if you already know about the system Verilog, and if you already have learned all the concepts in system Verilog, and if you just need a reference. Okay, when you are attending any interviews, if you just need an entire reference, then this video will be helpful for you. If you are someone who is first learning about system verilog course, if you want to listen this video you can, but this video will not be helpful for you. So my suggestion is I link the System Verilog playlist where I explain clearly about all the concepts that I am explaining today in detail. Okay, you can go there and check it out about the videos. But if you are someone who just want a reference for entire System Verilog, then this video will be helpful for you. Right? Hope I am clear about this. Now coming to System Verilog. So, in many videos, I have explained like what is System Verilog, what are its enhancer features, and all. So, I don't want to explain about that again and again. Basically, System Verilog is an extended version of Verilog, which is having many verificational capabilities which were inherited from OpenWeather. Right? So, what are these verification capabilities? Like you can see coverage, assertion. So, all are these randomization, constraint randomization. So, all are these verification capabilities of system verilog, right? Along with this verification capabilities, it has many enhanced features like oops concepts, right? So by using all these things, many companies are choosing system verilog as their verification medium in order to verify, yeah, their circuits. So, what is this verification? So, I have talked about this verification, like why do we choose this verification? Why verification is very important in design and in VLSI domain. Okay, I have made a clear video on that and I have uploaded it. If you want that, I linked it above. You can just go there and check it out. So, there I have talked like what is verification basically. From the name itself you can say that it is the process to ensure that the design that you are designing is working properly or not. So basically it is nothing but you will be checking whether the design or the circuit you have designed is working properly without any bugs or not, right? So this is the thing that the verification engineer do. So the design engineer will be designing and the verification engineer will be checking the bugs in that particular design. Basically design and verification domain does this work. Okay, so nowadays many people are switching their domains to design and verification from their regular domains, because in design and verification domain due to lots of work, because as I told you, in the entire front end like in the entire front end, verification team is very important. Okay, that doesn't mean the remaining teams are not important, but verification team has does a lot of work compared to the other teams, which is why more and more opportunities are going for design and verification engineers, right? So this is an opportunity for you to learn courses related to design and verification domain, and so that you can enter into VLSI companies for interviews also. If you are ready to give interviews, or if you need any updates related to any internships or else anything, I'll give the updates in my Telegram channel. You can go to my Telegram channel and you can join there. Right. So coming to verification, what is verification? So nothing but in order to make your design bug free, what you will do, you will be verifying it in all aspects. Like by sending all scenarios to that particular design, you will be verifying it in all aspects. So this is verification. For this verification, we need system verilog. Right. So what are the main features of system verilog? Just where now we have talked about that. Like the first thing is improved data types, and the synchronization between RTL and test bench is very important, which is enhanced in system verilog, right? And then assertions, coverage, oops concepts, constrained randomization. So these are all the important features. So if someone asks you what are the important features in system verilog, you can just choose this answer. Okay, so these are the system verilog features. Now coming to the test bench architecture, I'm not going to explain about this test bench architecture because I have already explained lots of times about this test bench architecture, and I have also made a videos on how to write the codes of generator, driver, scoreboard, and everything. Okay, I'll just attach the playlist in the description box, so you can go there and see how to write a codes on particular concepts like test bench, okay, environment, interface, so all these things, right? So this is about the test bench architecture. I'm not going to explain it. If you want the explanation, I'll link that in the description box, just like as told you before. You can go there and check it out. Now coming to first important concept in system verilog, which is data types. Okay, so these data types you already learned in system verilog, but what are the enhanced data types that were introduced in system verilog? Okay, so basically in verilog, if you see, in verilog you can observe only four state data types, but in system verilog there are both four state data types and two state data types. For four state data types means you can have zero, it will hold 0, 1, x and z values. But for a two state data type, it will be holding only 0 and 1 values, right? Again, in system verilog, you are having predefined and user defined data types. So basically, what are the predefined data types? Like all these come under predefined data types, that means they were already defined within the library. Whenever you want, you can just uh, uh, bring it and you can use it, right? Now coming to user defined data types, so basically in user defined data types you will be having many other data types like enums, classes, so all these are user defined data types, right? So this is the predefined and user defined, and among the predefined, these are the various data types that you can observe. Okay, so this is also one of the most frequently asked question in for the freshers basically. If you are a fresher in system look, this is the main important question, like which data type is having which state. Like if you see a shortened is of two state and a logic is of four state, right? Similarly, reg is of four state, integer is of four state. So you will be asked what is the difference between int and integer. Basically, int is 32-bit and integer also is 32-bit. Both we can hold the signed values. So why don't we use int and why do we use integer? Or else why don't we use integer and why do we use int? So basically the reason is that integer is a four-state data type and int is a two-state data type. When you want your variable to hold only 0 and 1 values, then you can use int. If not that the case, then you can use a four-state integer data type, right? You will be asked this question. So basically you need to know which data type is which mode, which state, which size, and what is the sign, like whether it can hold signed bits or both signed and unsigned bits, right? So this is about the data types in system verilog, right? This is one of the important concept in system verilog, and the next important concept is arrays. Okay, in verilog you have seen arrays, right? But you have seen only one array, which is um, fixed size array and dynamic array. But in system verilog you are having many versions of these arrays, like fixed size array, dynamic array, associative arrays, and queues. So these four are very important, and also arrays are really important in system verilog, which is why I have made a separate playlist on all these arrays, and I have made a separate playlist for this. I will also link that in the description box, you can go there and check it out, right? So this is about the types of an array. So coming to in today's video, since this is the at one go and this is just a reference video, what I am going to do is I'll be explaining entirely in one go. So that is why I am explaining brief about all the topics, right? If you want the detailed, like in detail, the brief doesn't mean that I'm not going to explain anything and I'm just giving the references or else like that. But if you want in detailed explanation, then you can go to the playlist and check the videos. Now coming to arrays, you are having four types of arrays, which is static array or fixed size array, and then dynamic arrays, associative arrays, queues. Like there is this one question among these arrays, like how do these arrays differ from each other, right? So coming to what is static and dynamic array, from the name itself you could say, if you want to fix the size of the array, the starting itself, then that is fixed size array. Okay, if you doesn't want to fix the size of the array at starting, and the size of the array will be fixed during the runtime, then that is dynamic array, and it is represented with empty box. Okay, if you are choosing the dynamic array, the syntax for that particular dynamic array is empty box, right? So this is the main difference between static and dynamic arrays. Now coming to what is the difference between dynamic array and associative array. Why is it? Because dynamic array and associative array also, you will be you doesn't give the size of that particular array at starting itself, but what is the main difference is that dynamic array can hold only small size of the arrays. Like if you want a huge size of the array, because when you are developing a circuit which is very complex in nature, then of course you need huge amount of memory space, right? When you are going for huge amount of memory space, then you will be choosing this associative arrays instead of dynamic arrays, right? And also, since it is very huge, what it will be done means, basically in dynamic array, while it is runtime, like while you are running the code, the size will be allocated, but during associative array, when you are assigning some value into that particular array only, then only the size is created. If you are not assigning anything, then the size is not created for associative array. Dynamic array is not that case. Like dynamic array, whether you are assigning the value or not, in runtime the memory will be almost allocated. Okay, so that is the main difference between dynamic array and associative array. Now coming to what is the main difference between associative arrays and queues. So basically, as I told you, for very large amount of memory allocations, you will be using associative arrays. But queue is not the case. So basically, here a queue is somewhat similar to dynamic arrays. Like in queue also, the size will be changed, it will be allocated, and it can be changed during the runtime. Okay, but the main difference between dynamic arrays and queue is, because as I told you, dynamic array and queue are somewhat similar. So let us see what is the differences between them. So basically, in dynamic arrays, even though the size is allocated and changed during the runtime, basically we can't insert or we can't delete it easy, all the elements at, like when you want to delete it, it is somewhat hectic in case of dynamic arrays. But when it comes to queues, you can easily push and pop the values or push and pop the elements inside the queue by using various other methods which are not present in dynamic arrays. Like if you see here, dynamic arrays consists of only three methods, which is new, size, and delete. Okay, but queue consists of many methods like push, pop in order to insert the element, and in order to delete the element, in order to shuffle the elements inside them. So it is having all these methods. Okay, which is why queues are more preferable compared to that of dynamic arrays. Okay, so these are some of the differences in static, dynamic, associative, and queues. So basically, and one more important difference between dynamic and associative arrays is that it's when you are using only integer data type, you can choose dynamic array. But when you are using any string data types, because string is not supported by dynamic arrays, so when you want any string data types, when you want to use any string data type, that is why if you see here, here the syntax is index type. So basically, when you want to include strings, then you will be using this associative arrays. Okay, along with this, there are a lot more differences, and this table will be helpful for you for reference. You can just pause this and check this table so that it will be helpful for you. If you have any doubts in this table, you can just ping me in the comment box. I will definitely answer your questions, right? So recently many of you pinging me in comment box as well as my LinkedIn also. Since I'm not uh, I'm not present on this YouTube and all recently, so that is why I am a bit busy with my personal work, so that is why I can't reply to your comments. I'll definitely reply your comments as soon as possible. Right, so this is about the second important topic in system Verilog, which is arrays. Okay, hope you got an idea on what are arrays. Now the second thing, the third thing is, this is not that much important, but not uh, not comes under the case where we can leave this particular topic, like structures and unions. Okay, recently many of them are uploading their interview questions on LinkedIn. Okay, where I have pointed out these where I have seen this structure and union questions in two or three persons are mentioning about the structure and union questions. So that is why I want to include this also in this system Verilog uh, topic. Right, coming to what are structures and unions, basically we have talked about arrays, right? So in arrays, what is an array? Basically, if you want to have a group of elements with same data type, when you want to assign group of elements to a single variable, then you will be using arrays, is it or not? Similarly, when you want to have a group of data types in a with one name, okay, when you want to pack a group of elements, when you want to group the different data types, then you will be going for this structure and union. So if you see here, this is what I'm talking about. So structure, basically for array, if you see, int array of for example, let us consider this int array of 5 down to 0. So what does this mean? This array is of int data type, where this array can hold integer values with size of 0, 5 down to 0. That means 6 elements it can hold. ARR is a variable which can hold 6 elements. Similarly, struct is the group which can hold two different type data types. Okay, right? So that is what I'm talking about. Like, that is the main thing you need to remember while you're talking about arrays and structure. Just like single data type, different elements in array, similarly single group with different data types for these structures. Okay, basically both structures and union also does the same thing. Okay, but there may be some differences between structures and unions, which we'll be talking about in the next slide. Right, so this is about the structure. Structure is nothing but it is the collection of elements having different data types. Okay, just like collecting elements of same data type is array, collection of different elements with different data types is nothing but structure. Union is also the same thing. Okay, so you can access all these elements, or you can access all these different data types at a time, or you can access this individually also. Okay, like enums, these can be used as structures, and utils also come under the user defined data types. Okay, when a structure is declared, the memory is allocated. Okay, when you are declaring structure, that means when you are declaring with a struct and struct name, then the memory is allocated to all the members within this structure. Okay, this is where the structure and union differs. Let me explain it in the next slide. So basically, this is how you will be writing. So if you see here, this is arrays. Okay, int array of 10, that means it is holding all elements which are int data type. Similarly, here if you see, all elements which are bit data type, but here this is structure, so that is the difference. So here if you see, this structure consists of value 1 which is of byte data type, value 2 which is of int data type, value 3 which is of struct data type, string data type, right? So all these are grouped together in a struct. So when you want to access all these things, you can either access all these things at a time, or you can access these things individually. Basically, structures are used in writing a codes. For example, if you want to generate the salary, or if you want to generate the if you want to generate the students ID cards. Okay, so your the student ID card consists of his name, his father's name, his blood group, right, his ID. So all these things, when you are generating the student ID card for some 50 or 100 members, then basically you will be writing a code by using the struct data type. Right, hope this is understood. Like, now coming to, as I told you, structures and union is both are both same, like they both will be having different elements, like both are nothing but collection of different data types. So what is the difference between structure and union? So structure is declared with struct keyword. Similarly, union is declared with union keyword. The same thing. Like if you are writing here struct, then it is structure. If you are writing union here, then that is union. So what is the difference between structure and union data type? So basically, in structure, whenever you are declaring the structure, then as we talked about before, the memory is allocated all the variables within the structure, all the data types within the structure. But in union, that is not the case. For example, if you see byte, int, and string, so among this, int can hold 32 bits, so which is why the highest data type value will be given the value, like memory assigned. That means the 32-bit size is assigned, the 32-bit memory locations are assigned. Byte and value are also, which is why if you see here in union, we can't access all the members at a time. Individual members can be accessed, only one member can be accessed at a time. Why? Because here if you see in structure, you are assigning memory to all the value 1, value 2, value 3. But here in union, if you are using union here, you are assigning value to only value 2. That means you are assigning memory to only value 2. And value 1 and value 3 will be sharing the memory location of value 2 itself. Which is why this is just like if you are having three bedrooms, if you are three members and having three bedrooms, then all the three of you can be using three different bedrooms. But if you are three people and if there is only one bedroom, what you will do? You will be sharing. Okay, you will be sharing or anything like that. Okay, just hope you understood about it. Okay, so this is about the structure versus union, right? Now coming to the important concept in system Verilog, which is enumeration. Okay, so what is this enumeration? As we already talked about this enum, it is the special data type. So basically that is a user defined data type in system Verilog. Okay, just like structures, unions, enumeration is also a user defined data type, and also the classes are user defined data type. So why do we use this enum? So basically enum is used in order to name the integer constants. Okay, for example, okay, let me give you a clear example for this at the starting itself. For example, if you are writing a code for a traffic light signal. Okay, so in traffic light signal, let us consider we are imagining that like we want our code to be, if one, then red should be on, if two, yellow light should be on, if three, green light should be on. So 1, 2, 3 are the values that we are going to write in our code. Now we, since if you are generating the code, then you understand what is 1, what is 2, what is 3. But if someone want to understand the code, or if for example if a you are designing the code will be going to this verification engineer. Now the verification engineer should understand whether he should give one first, or say two first, or three first, is it or not? So basically in such a way, for example if you are working on finite state machines, the same thing, like you are generating a sequence where for example 100 means one output should occur, 101 means one output should occur. So if you don't know what is that 100 stands for, then the verification department doesn't understand how the code was created, right? So which is why enum was introduced in system Verilog. So basically what enum does is we are naming the integer constant. That means we are telling that 1 means red, 2 means yellow, 3 means green. Similarly 100 means one state, first state, 101 means second state, 102 110 means third state. Similarly we are giving the states, we are naming it. Okay, so the naming is nothing but enum, simple. Okay, so For okay, let me give you example for that. So that, for example, if you see here enum, okay, you will be giving the value. This is the constant, so you need to give the values 3, 4, and 5. Instead of giving the values 3, 4, and 5, you are naming it as red, yellow, green. Similarly, if you want to have states like ideal, setup, and access states, okay. So now what happens if you are giving the values ideal, setup, and access as 1, 2, 3? Then the particular person doesn't understand whether one is setup state or access state or ideal state. So what we are giving, we are using the enum in order to assign the integer constant a name. Now the he will understand, like ideal is, that means if you are giving 6, then the ideal state occurs. If that is 9, then setup state occurs. If it is 14, then access state occurs. So in this way, you are naming the integer constants. Just naming the integer constant is enumeration. That's it. Okay. So this is the syntax for that enum, right? So this is how you will be using. In enum also, you are having lots of methods like first, last, next, okay, next of, and previous, previous and number, name, all these things. Okay, you can just check the full length video in order to understand what is this enum and all. Now coming to the most important concept. This I didn't explain in any of my videos in system Verilog, because I think this is not essential, because everyone learn about these loops. But recently, many of the students are asking about this video, which is why I'm going to explain this in this particular video. So, coming to in so Verilog also, you are having lots of loops like for loop, while loop, okay, forever loop, like that. But in system Verilog, there were some more loops which were introduced. So the first thing is, first loop was do while loop, which was introduced in system Verilog. For each loop, okay, repeat loop. So these are the things that were introduced in system Verilog. So while loop, you already know, if you are familiar with C language, or if you are familiar with any language also, you will understand what is while loop. So basically, while you will be giving the condition. If the condition is true, then the simulation will be done. Then the statements within the while loop will be simulated. If not, it will be exiting the simulation, right? This is while loop. So the same thing is it do while loop also. But the only difference is that if you see the syntax here, for while you are writing the while condition begin and end, but here first you will be mentioning do, begin and end, while condition. Now what happens, because in while loop, if the condition is false, at least one statement also won't be executed, because it doesn't enter. If the condition is false, the simulator don't be entering within the state, it won't be entering into the loop, and the statements within the while loop are not executed. But in do while loop, since the condition is last, so what happens, first at least one statement will be executed. Okay, if you see here, if you see the code here, in count is 2. Okay, I'm giving do while. So what happens, since count is 2 and the condition is while count is less than 1, it will be executed. So what happens, first at least value 1 statement will be executed. Now it comes to check the condition, 2 is less than 1, which is false, so it will be exiting the condition. So that is the difference. So in while loop, no statements will be executed if the condition is false, but in do while loop, at least one statement will be executed without checking the condition. Clear, right? So this is the difference between while and do while. Now coming to forever, this you have already learned. Like forever means, if you are giving the condition, or if you are giving the statement within the forever, then it will be executed conditionally, unconditionally, until n number of times. But if you want to break that particular forever group, forever loop, what you have to do, you will be using the break statement. Okay, so what you are going to do, forever, if you see the condition here, forever begin, I want to display value of count. Okay, so count plus plus. So what is value of count? Since I didn't give, first it starts with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, it will be forever until 10, 11, 12, until it will be going until infinitely. But in order to break it, I have given a condition. What? And after writing the forever, I am breaking it with condition, if count equal to 0, break it. So it will be breaking the condition. which is why it doesn't enter into infinite loop, right? So that is the forever, and in order to avoid forever, we'll be using the break statement. Next is for loop. I don't want to explain for loop because it was already, I think you have learnt about a for loop. Now coming to for each loop. So just like for loop was introduced for basically conditions or for individual integer values, similarly for each was a special type of loop which was introduced for arrays or queues. Okay, when you want to iterate the elements within the array, or when you want to iterate the values within the queue, then you will be using this for each loop. Okay, for each, because if you see here, if you want to iterate the values within the array, then it is really hectic process when you are using a for loop, because in for loop you need to write the initialization, condition, update, all things you need to write, and again you need to write the condition. So this is all such a hectic process. So in order to avoid it, for loop was introduced in System Verilog, where just you can avoid all these lines by using a single line, which is for each of array of I. But remember that for each loop is only introduced for arrays and queues. So you can use for each loop for only arrays and queues, right? So array of I. So basically, when you want to, so similarly, you if you are writing for each array of I, so all the elements within the I will be iterated themselves without writing any other condition, right? So this is about the for each loop. Next is functions and tasks. Functions and tasks is very important, but I'm not going to discuss it since we have already discussed it at a very long. If you want to know about it, I'll link the videos related to functions and tasks that I discussed in the uh, Verilog course in this description box. You can go there and check out, right? Now coming to the another important concept in System Verilog, which is System Verilog process. So basically, System Verilog process is nothing but, for example, if you want to, what is function and task? Basically, function is nothing but piece of code. Is it or not? Similarly, process is also a piece of code which will be executed parallelly. For example, so when you are designing complex circuits, or when you want to verify complex circuits, there may be situation where you need to run certain piece of codes parallelly, certain number of codes parallelly. So what do? You'll be using this very system verilog process concept, where all the working will be done parallelly. Okay, if you want to run certain codes, then you can run all the codes parallelly. This is where you'll be using the system verilog process. When you want to run number of functions, or when you want to run number of codes parallelly, then you will be using the system verilog processes. So again, system verilog processes are categorized into fork join any, fork join none. So based on how you want to run these codes, you can use any of these flavors like fork join any, and fork join none. I have already made the separate playlist on this fork join processes. I'll link that in the description box. You can go there and check it out, where I have explained lots of examples, because system verilog process is the most frequently asked question when you attend to any interviews or internship return test. But this is where many of the students will be losing their marks, because this fork join any, fork join, how many times you read it or how many times you practice it also, it will be very confusing. Okay, so which is why I have made separate playlist where I have explained every example on this fork join any, fork join none. Okay, if you are also having any doubts on fork join any, fork join none with examples, you can just ping me in the comment box, or you can join my telegram channel, or and there you can ping me, so that I'll explain that examples also, because I have received many examples from fork join processes. I'll be receiving today also like many examples. I try to solve them and I try to explain them in my videos, right? So this is about the fork join processes. Basically, fork join any, fork join none is nothing but, for example, in fork join, what happens if you are having, for example, three codes, if you want to run three codes within your fork join process, then until all these three codes are completed, like until all these three processes are executed successfully, then only the fork join process will be, then only the simulator will be coming out of this fork join process. But in case of fork join any, what if any of one of the code is executed, like if any one of the thread, let us call them as threads. Okay, if all these threads are executed, then only the simulator will be coming out of that particular fork join process. But in fork join any, if at least one of this thread is completed, then it will be coming out of fork join any. And if outside the fork join any, if there are any other codes that need to be run, they will be run parallelly along with fork join any process. But in case of fork join, that is not the case, because in fork join, until all the threads are completed, then only outside the fork join block, if there are any codes, those will be executed. But in case of fork join any, if at least one of the thread is completed, then all the codes that are outside this fork join any also will be running parallelly, right? When coming to fork join none, what happens? Those will be running parallelly, and outside the block, if there are any threads, they will also be running parallelly, right? So here it doesn't consider about whether the threads are being completed or not, but they will be running parallelly. Whatever threads that you are mentioning within the fork join none, they will be run parallelly. Along with that, the outside, if you are using based on the blocking statements, non-blocking statements and all, they will be executed sequentially or parallelly. Okay, so this is about the fork join any, and fork join none. So now, if you are using the fork join any, and fork join none, and if there comes a situation where you want to stop this particular execution of statements, then you will be using the disable fork. When you are using disable fork, then that means the fork join process that you are using will be stopped there. Then until then, all the things will be running parallelly, and once you are disabling that fork, the fork join process will be disabled, right? So this is about fork join disabling. Now there is one more concept in fork join, which is wait fork. So basically, when you don't want to disable that fork join, but you want to make the fork join. For example, if you see here, as I told that in fork join any, only one statement will be executed. If any one of threads will be done, then it will be the simulator will be coming out of the particular fork join any, and then the remaining code outside the fork join any will be executed. But when there comes a situation where you need to use, because they will be asking the questions in interview in such a way like, you need to execute all the threads within the fork join parallelly, but you shouldn't use fork join, but all the until all the threads within the fork join will be completed, the remaining statements outside the statement shouldn't be used. So how you are going to do it? Basically, you will be using the wait. So what wait does means the same work what fork join do, wait also does. Okay, that means until all the threads are being completed, it will be waiting, and then it will be ending the simulation, right? So this is about the wait for. Now coming to the important concept in system. Next important concept in system Verilog, which is OOPS concept. Okay, OOPS consists of inheritance, polymorphism, encapsulation, data abstraction. So all these four properties are very important in system Verilog. And also, yes, since it is very important, I have made a separate playlist on it, and I'll also link that in the description box. Like, for your convenience, I have made all these videos in one single playlist. Also, based on the importance, I have created separate playlists for all these concepts, right? So I link that in the description box. You can go there and check it out. So firstly, let's discuss today about what is inheritance, polymorphism, encapsulation, and data abstraction. Okay, now coming to inheritance. In this video, I'm not going to explain you with codes, because I am uploading videos on how to write a code for all these properties. Okay, soon they will be uploaded in my channel. Okay, please do wait for it. So in today's video, what is my aim is, I want you to explain about this inheritance, polymorphism, encapsulation, and data abstraction, so that you will understand what are those and what is the difference between one another. Okay, so now coming to inheritance. Okay, I'm going to give you examples so that it will be easily understood for you. So first, let us consider inheritance. Inheritance is nothing but, for example, if you are taking vehicle as an example, so vehicle is the parent class. So what categories come under vehicles? Cycle is a vehicle, scooter is a vehicle, car is a vehicle, right? So all these come under the base classes. Just like Vehicle. What does the vehicle consists of? Vehicle consists of tires, vehicle consists of a seat, vehicle consists of brakes. So all these are general categories. So all the general categories will be present in vehicle, right? Now similarly, every, for example, cycle consists of all these tires, brakes, and then a seat and all. So along with this, what does it consist of? It consists of its individual properties. Similarly, bike consists of some more important properties compared to that of vehicle, like it consists of gears, right? Like similarly, it consists of engine, so or motor, like all these things. Similar, sorry, motor and all. Now coming to car, it consists of some more properties like engine, like seat belt, like gears, so all these things. Similarly, for truck, it consists of its individual. So just like vehicle is the parent class, all the cycle, scooter, car, all these are base class. Just like parent class will be having its properties and methods, base class will be having their properties and methods. But base class will be inheriting all the properties and methods of parent class. Okay, along with the properties and methods that the parent class consists of, along with their properties, like just like vehicle consists of what are the similar properties like chain, seat, okay, brakes. So all this will be present in both car, cycle, scooter, car. All this consists of all these things. Along with this, bike consists of two tires, car consists of four tires. Truck consists of some six tires. So basically, along with the properties that they inherited from the vehicle, they will be having their individual properties. That is inheritance. Just like the parent class is having properties and methods, child class also have properties and methods. But along with the properties and methods of child class, it also will be inheriting the properties and methods of parent class. Right? So we can access all the properties of parent class by using the child class. That is inheritance. Right? Hope you got it. Now coming to what is polymorphism. Okay, polymorphism is nothing but, for example, I am a teacher. Okay, for example, I am a teacher who will be teaching different subjects. Okay, me is one. Okay, I am one, but I can teach English, I can teach Hindi, I can teach Telugu. Now, what is having the me is the one, right? This base class is what me, I am base class. So just like I can teach many, like I am different, I'm a Hindi teacher in one class, I'm Telugu teacher in one class, I'm English teacher in one class. Even though it is me, I am in different forms in different classes. That is polymorphism. The base class is one, okay, but it is having different forms in different base class child classes. That means if just like I am a Hindi teacher in one class, similarly base class is having one property in one child class. I am Telugu teacher in one class. Similarly, base class is having some other form, is in other form in second child class. I am English teacher in one class. Similarly, the base class is one more form in the third section, right? Similarly, in this way I am having the me is one, but I am having different forms in different classrooms. Similarly, the base class is one, but it has having different forms in different child classes. That is polymorphism. That means the one base class is having many forms, right? That is polymorphism. Now coming to what is encapsulation and data abstraction. So basically, first let us discuss about what is data abstraction. Data abstraction is nothing but, for example, let us consider you are taking, you are preferring, you are generating ID cards for the students. Okay, so what does your ID card consist of? The ID card consists of, just like we have talked about before, like some student name, student ID, his blood group, his father's name, maybe his address. That's it, right? So, does this ID card consist of all the information about the child that the school consists of? No, right? Because the school attendance or the school form consists of all other things related to child, like what is his health conditions, what are his allergic conditions. So nowadays, every student, every school is asking parents to fill forms related to the entire child thing, but are they going to display their entire form in the id cards? No, right? Similarly, data abstraction means even though the base class consists of many properties and methods, but it will be showing only some properties that are important for the child class. Okay, just like in id, it requires this information. For example, if you are going for a child's progress report, then does this consist of all this information? No, it consists of only the child and his marks, right? And his performance in the school. Does the id card consist of performance? No. So that is the difference. This is where we use data abstraction. Clear? So that means even though the base class consists of many properties and methods, it will be displaying to the child class based on the preference. Like what the child class needs, those only it will be doing it. So that is data abstraction, right? Now coming to encapsulation. Encapsulation is similar. Many of you are having doubt about this encapsulation and data abstraction. Like what is the major difference between encapsulation and data abstraction? Like basically, encapsulation is nothing but you are hiding the particular, you are protecting some particular properties and methods of the class. Why? Because generally it is just like if you are having a house and if you want to go outside. So basically, when you want to make something some places in your house to be protected, but you want to give the key for cleaning to your particular house help. So what you will do, you will be giving those keys which doesn't require any security to the house help, and those rooms are those things which need security, you will lock them yourself and you will be taking the key. You won't give that key to the particular house help, right? Similarly, in encapsulation, what happens means when you want to protect certain properties and methods, you will lock those by using certain keywords like local and protected, and you lock them so that no one can access them. That means you are hiding certain properties and methods by using some locks, and you are so that they are visible to the particular person, because in data abstraction, the class, the properties and methods are not visible to the child class. That means they are not you can't have the entire, just like id class doesn't contain all the information, similarly the child class also doesn't contain all the properties and methods. It will be only taking the properties that the parent class shows. Similarly, but in encapsulation, what happens, it will be protecting them. That means you can see it but you can't access it. You can see the lock, you can see the particular locker, but you can't open it because you didn't have the lock. You can't open it, you can just see it, right? So this is the difference between encapsulation and data abstraction. Hope you are clear about this. Oops phs, if you are still having any doubts, you can link me in the description box, right? So this is all for today. In the next video we'll be talking about some more important topics which will be starting from classes, right? Hope you are clear about it. Hope this video is helpful for you. If you like this video, please do give it a like so that it is kind of inspiration for me to upload more such videos. So this is all for today. Thank you all.